Okay, so let's continue the last part of number 20. So let me make this a little bit bigger so you guys can see. Okay, so we have, from the last video, we found out that r could be 0 or it can be a third. So remember that these guys were the exponents that we obtained earlier. So remember that C naught, really represents our AN, BN. It's just a general C naught, or I should say A naught, B naught. So I can say that A naught and B naught can be any number here, as long as, right, this is true. So recall that, make this a little bit bigger again. Recall that, right, we chose, we're assuming that y is a power series solution. So we had this guy when we did our substitution. And remember, we found a y1 and y2. And so I went ahead and I just inserted, right, our r's. That's a third, and then that's a 0. And remember that a naught and b naught cannot be 0. Because if a naught, if these terms are 0, then we're just really adding a bunch of zeros, right? This is a summand, so 0 plus 0 plus 0, well, is just 0, and that's not very interesting. So that's why these guys cannot be 0. Now there's two things going on, or I guess there's going to be two cases here. We have where our index starts at 0 and then everything after 1. So if n is greater than 1, right, or at least 1, then I have this guy. And if you want to, this is really the summation here. And from the last, you'll see it in the last video, you'll see this term. This is where I'm getting it from. And this should be familiar in the sense of, finding the recurrence relation, right, and equating the coefficients. So I have this guy, and all I'm doing is just some algebra, right? I factored out an n plus r, c to the n, right? That was in common. And then I just solved for cn. And again, I just distributed here because we can distribute. So here's my nice cn term. And we know r1, so there's two cases because I have two r's. So if r1 is a third, which is case 1, okay, I'm going to use this recurrence relation. So notice my cn minus 1s become an minus 1s. And all I did was I substituted a third, right? N plus, that's a third. That's a third. And again, I just simplified a bit, right? Just probably FOIL and multiply this guy in, and again, combine like terms. So that's where I got this this guy from. And moving on, this is the next page. I hope it lets me. It's not letting me shift here. Okay, let's see if we can work with this guy. Okay. So we want to find the 5. First, we could be 4 or 5 terms. I just chose 5 of the sequence. So remember, this is my recurrence relation. So if a naught is 1, okay, and I obviously use this a naught here. Well, if n is 1 here, again, we've done this many times. A1 is going to be negative 1/2, right? A2, right? Just do the math. It's going to be a fourth. A3, and so forth. So we found our ANs, right? This is, you can do ... I just, again, did 4. Then we find one series solution, right? We have x to the r form, that Frobenius form, plus this series. And now with you can do this similarly with R2. That's just case 2. And you're doing the same thing that you did with you're finding your AN here. We're just calling it BN because it's a different solution. And you're letting B naught, right, B1. And again, finding B1, B2, B3, and so forth. Now, you might, one of Michael Roth, who he asked me in an email, what's the difference between 3.1 and 3.2? Because it looks like we're doing the same thing. Now, this is 3.3, but it's still Frobenius solution. Now in 3.1, when you found the series solutions, So this here's 1, and where's my other one? My y2 is right here. So here are my 2 guys. And the difference is that, I mean, you do have these power series solutions, but this series, right, you can't write this series in terms of an elementary function that you did in 3.1. That's the only difference. The process is exactly the same, but you know, it's great when we can write a series solution in terms of elementary functions. But in this case, you cannot write this in terms of an elementary function. So that's the difference. So that is finally the end of number 20. So remember, there should be some VPs coming in for number 19. Make sure you know how to do number 19 for your test. Hint, hint. It's very, very important. So make sure you understand how to do that problem. Again, it's very similar to 20. Please ask me questions on number 19 if you're stuck, especially if you're doing a presentation, and I'd be happy to give you hints and fill in any gaps that you may have.